Hi, this is Mrs. Ziegler, and I'm going to go over how you are going to complete the crisscross method for ionic bonds. So what we are going to do is we are going to look at creating chemical formulas and writing the names for chemical formulas for ionic bonds. So remember, ionic bonds are bonds between metals and nonmetals because the metals will lose the valence electron in order for the nonmetals to take them. So in the very top, it gives you directions here as to what you're essentially doing in order to do what's called the crisscross method. I also call it the drop and swap, depending on which way that you want to take a look at writing your chemical formulas. So this is how we write chemical formulas when given different elements, and then this is how we name them once we make our chemical formulas. So for example, here I have lithium and chlorine. So you'll need your periodic table in order to complete this, in order to know what the charges are and what the symbols are, and then writing your chemical formulas and chemical name. So first one is we have to look up the charge for lithium. So we know that lithium is the chemical symbol Li. It is in group 1A, so therefore we should know what the charge is. For chlorine, we know the chemical symbol is Cl. So again, Cl is in group 7A. So we know lithium's in 1A, so therefore its charge, if you look at your periodic table, is a +1. For chlorine, it's in 7A, so therefore it's going to be a -1. Remember, the way that we find our number of charges is based off of how many electrons are lost or gained. So that is how we get our charges. Then we do our chemical formulas. So doing the crisscross method, what you do is you write your two chemical formulas next to each other like this, and then you're going to take the charges. So these are the charges of these specific ions. So what you'll do is you'll take the number, not the charge, but the number, and you'll crisscross them. So that means that this one is going to go, well, actually, we'll go with this one. This one is going to go here, and then this one is going to go here. I also call it drop and swap because what you do is you would drop the charges and you drop them down as subscripts, and then you swap places. In this case, they are 1 to 1, so therefore you can either write the ones, but 9 times out of 10, you can just drop the ones and you don't have to write them because it's understood to be 1. Now, when writing the chemical names, so remember the first element is just its name, so it's right there, lithium. The second ion name, which is where we have to chop off the end and add the suffix of IDE, so this would be chloride. Next one, so I have sodium and oxygen. So again, for sodium, our symbol is Na, our symbol for oxygen is O. Looking up our charge, it is in the same group as lithium, so it's a +1. Looking at oxygen, it's in group 6A, so therefore it'd be a -2. Because remember, it's a metal, it's going to lose all of its valence electrons. It's a nonmetal, it's going to gain valence electrons to have a total of 8. So if it's in 6A, that's the reason why it needs to gain 2 to get to a total of 8. So therefore, it's a -2. So I write my chemical formulas, and then I'm going to do crisscross. So since the 2 is here, I'm going to write the subscript 2 here. Since there's a 1 here, I'm going to write the 1 here. Again, if you want to think of it as crisscross, that means that this 1 goes here and this 2 goes here. Or if you go drop and swap, these drop the charges and subscript, and then they swap places. Then we just name them. So first name is sodium. Second name is oxide, and that is how we do the crisscross method for writing chemical formulas and then naming these chemical formulas. We will learn how to name covalent, which is a little bit easier, but this is how we do ionic compounds. If you have any questions, make sure that you reach out.